For part A, we have two electrons that start some distance apart and at rest, which means their initial velocity is 0. In order to draw the energy graph, we are first going to start from the energy principle that says change in energy is equal to the change in kinetic energy plus the change in potential energy. For potential energy, we're going to use potential energy for electricity, which is this. And because both of our charges are negative, because we're dealing with electrons, that is going to end up being positive. And then for kinetic energy, we have 1/2 mv squared, and because our velocity is squared, that will also be positive. And then we are going to start with our potential energy, which looks like this, because the electrons start at a distance apart. And then because we all know that our change in energy is going to be equal to 0, we know that our kinetic energy is going to look like that. It's just going to match the potential energy with our initial being right where the potential energy is at its top and where kinetic energy is equal to 0. And then we know that our total energy is going to be right along the top here, so that when the two are added together, they always equal the same thing. In part B, we have a comet approaching the sun from far away, but it does not collide or orbit the sun. We are going to start with the energy principle, which is change in energy equals change in kinetic plus change in U, and then we're going to use our equation for potential energy of a system that is not on Earth, which is negative G times M1, M2 divided by R, and then because that's negative, we know that is going to be a negative value. Our equation for kinetic energy is again 1/2 mass times velocity squared, which is going to be positive again. And then on our graph, we will draw our initial position. And then from that, we know our potential energy is negative, so we'll go ahead and draw that. And then we know our kinetic energy is going to match our potential energy, so we can draw that one. And then from there, we can draw our total energy, which is going to be positive. In part C, we have a spacecraft that leaves Mars with an initial velocity below the escape speed for Mars. Again, we're going to start from the energy principle. Energy equals kinetic energy plus potential energy. The equation for potential energy is going to be the equation for potential energy not on the Earth, which is going to be negative, and kinetic energy is again going to be 1/2 mass times velocity squared, which is going to be positive. That's negative. Okay, and then we're going to draw our energy graph. We first have our initial position, and then we will also have a max position because the energy for this system is bounded, and that means our energy is going to be less than 0 because the spacecraft never escapes the escape speed. So then we're going to draw our potential energy, which is negative, our kinetic energy, which is just matching that potential energy and going towards 0, and then our total energy, which is going to be less than 0 because it is a bound system.